All right, okay, question 6. Figure 5 shows the start of an algorithm. Another algorithm question. Notice these all come from the same exam paper. Got to sort out algorithms and pseudocode. You must make sure that you can read and write pseudocode. Okay. The start of an algorithm. Output. Well, what is output? That's a bit like print, isn't it? In Python, print. Enter the 24-hour number, 0 to 23. And then hour gets assigned to user input. So user input is a bit like in Python input, and then our input function, which returns a string. Okay, well, in Python code, we have to differentiate between inputting strings and integers. So if the hour is actually an integer from between 0 and 23. In Python, we would have to say something like hour equals input, and then it needs to be an integer, so we need to have an integer here with bracket input and then the prompt. But in pseudocode, you're allowed to sort of just make the assumption that user input will be the right type, will be the right type. So this is going to be an integer. It's worth bearing that in mind. So we don't need an int here. If we put it in, we wouldn't be penalized. The algorithm in figure 5 asks the user to enter a number between 0 and 23 that represents an hour using a 24-hour clock. And as you know, 24-hour clock is a bit like the modulus operator. The clock goes from 0, 1, 2, 3 up to 23, which is 11 o'clock, midnight, and then 12 o'clock becomes back 0 again. The input is stored in a variable called hour. Extend the algorithm in figure 5 using either pseudocode or a flowchart so that it outputs the equivalent time using the 12-hour clock, i.e. a number between 1 and 12, followed by either AM or PM. Right, okay. So, for example, if the user enters 0, it should be 12 AM. If they enter 4, it should be 4 AM. If they're 12, it should be 12 PM. Okay, so basically what have we got here? We've got anything that goes from 0 up to 11, that's going to be AM. And then 12 up to anything with 23 goes PM. And notice that it only allows input, or theoretically only allows input from 0 to 23. Okay, so let's see what we can do. We can assume that the variable hour is an integer and the value that user inputs will always be between 0 and 23. So we don't have to worry about erroneous data coming into this algorithm. Yeah, obviously, if you were programming this in real life, you would, but not for this question. So what do we need to do? Okay. Extend the algorithm. So we can assume that these two lines already exist down here, and we're going to extend it. So what do we need to do? We need to check some, obviously, if statements. We need to see if the number that's been put in, which is the hour, is between 0 and 11, so we need to be greater than or equal to 0, and we should probably put and as capitals. It doesn't, you'd get away with it not having it as capitals, but and hour is less than or equal to 11, then we're going to have this little piece of text, sort of the AM PM indicator. So this is sort of, what could we call this? The AM PM, we could call it that. AM PM is equal to AM. Okay, so in other words, if we're between 0 and 11, then it's AM. Else, well, anything else is going to be PM. So our AM PM is going to be PM. And notice we've got quotes here, okay? Because they're strings. This is a string, this is a string. Okay, so we're declaring this to be a string. This AM PM is a string. Right, now, what do we need to do here as well? So here, the hour is fine. So here we've got the situation where what happens if they type 0? Well, if they type a 0, it should say 12 a.m. Okay, so we need to cater for that. So let's just shift this down a little bit. Obviously, in your case, if you've already written that, you'd have to rub it out and move it down. So that goes down here somewhere. And inside the fact that we're dealing with the fact is hour between 0, we can say if the hour is equal to 0, then, I should probably be consistent and have if as capital, then what we're going to do is we're going to set hour to 12. And by the way, this is assignment here, so we should have an arrow. So install, remind me later. This should be an arrow, and this should be an arrow down here because we're using assignment. We shouldn't use equals as an assignment. Equals is comparison, equality. Then hour is 12. So this is this special case in the fact that if we put in 0, so we're going to have 12 a.m. because 0 is just past midnight, which is 12 a.m. Okay, so that deals with that. But in the case where we've got in the afternoon, then we need to subtract 12 from the value, because if they put 13, that's going to be 1 o'clock. So 13 hours, that's 1 p.m. 14 hours, that's 2 p.m. So you can see here that in order to do that, we subtract 12. Subtract 12. So in the case of the afternoon, our hour is going to be assigned to hour minus 12. We need to subtract 12 there. Okay, and what should it do? It should extend the algorithm so that it outputs the relevant time. So we need to do the outputting bit. So after we've done all those comparisons, we're then going to output our AM, PM, and our hour. So we're going to have hour followed by our AM, PM. Okay, now obviously we were doing that. You really should be thinking about doing this in pencil, because you're going to perhaps be wanting to put in bits of code in the middle. Let's just go through that again. So we're saying if the hour is greater than 0 and less than 11, this is the morning basically. So if you had a comment in here, then this is morning. Then we've got our morning indicator, AM. And if the hour is actually 0, then our hour should be 12, so it would be 12 AM. We need to cater for this special case when the hour is 0. If it's in the afternoon, then that's going to be 13, 14, 15, up to 23. So we need to subtract 12 from that to get the correct hour. And then we're going to output our hour and then our AM, PM indicator. Okay, so that's if you're doing it in pseudocode. What about if we're doing it a flowchart? Well, remember, first of all, a flowchart needs a start. We're going to have our existing bit of code that we're given in the question in here. So that's going to be our output. Enter the 24 between 0 and 23, and then we're going to have our hour gets assigned our value of user input, and then after that we need a decision now. So we're back up. We're now looking at this part of the code here. So if is a decision, so we're going to say is the hour greater than or equal to 0 and hour less than or equal to 11. If it is, then we're going to do this code here. Then we're going to have our AM, PM counter. So we're going to set our AM, PM to be AM. And we're also then going to make a decision about whether or not the hour is 0 or not. So we're coming down here, and then we're going to do, if the hour is 0, so if hour is equal to 0, if that's true, or yes, we can't say if then, we'll say is hour equal to 0. Is hour equal to 0? If it is, then we want to set the hour to 12. So there's a little process here. So we said hour is 12. If not, then we're just going to come down and not do anything else. So this is going to come into here like that. If this was not true, then we're sitting, this bit is looking at here, this bit of code here. So we're going to set, so this is no, the AM PM calculation to PM. And then we're also going to set hour to be hour minus 12. And then afterwards, whatever we've done, we're going to come down here and we're going to output. So we need this parallelogram, and we're going to output our hour followed by our AM PM. And then remember, we must have an end. Okay, so that's the pseudocode. This is the flow chart. So just sort of color code this a bit. This thing here is this if statement. The bits right at the top, these bits here, well, that's just this bit. Okay, and if this is the case, then this green is this bit, and then this, let's say this is dashed pink, that's this bit, and then let's say this is hour is 12 with a rectangle around it, that's that one. And otherwise, no, this coming down to this cyan bit, this is, if you like, the else, that's that bit. And then these two things are here. And then basically this output thing, let's circle that, that's this bit.